So last time we started the curvilinear motion. So we talked about over the last week the linear motion. If the body is moving on a linear path. So the curvilinear motion is almost the same thing, but the body's not on a linear path, but it's moving on a curve. So we'll be using the same rules, but we need to deal with two components of the movement, because if the body is not moving linearly, so it's just, we can say s minus s node, or the distance just in x direction, but right now our body is moving in xy direction. The time rate of change of the velocity, it changes in x, it changes in y. So we talked about that there's different coordinate systems that we can use to solve this body. Some of them will be Cartesian, like xy coordinate system. Others it's going to be polar, like r and theta, if a body is moving on a circle. So you have r and you have theta, and r and theta is changing over time. And there's also tangent and normal if the path is not circular. So if it's not circular, so it's kind of like any curve. So we will know how to deal with tangent and normal. Okay, so let's start with, I don't know, like you guys last time had problems with these screens, but I believe that's the best position. All right, so let's start with curvilinear motion in Cartesian coordinate system. Chapter 12.5. So we have Cartesian, which means x and y coordinate system. And we are talking about curvilinear motion. Curvilinear motion again, that you have, this is x, this is y, and you have a curve like this, and your body is keep moving on this curve. So if this is the position of your body, it's keep changing over time. Always the velocity is tangent to the curve. So if my body is moving over this curve, at any time the velocity is tangent to this curve. Like here the velocity was like this, here the velocity was like that. So this is v, and it has two components, it has vx and vy. Alright? And if I want to write the components, so we have r vector, it has a component in rx, which is this, and this is ry, so rx in the direction of I hat, plus ry in the direction of j hat. Same thing, the velocity vector has a component vx, which is this one in the direction of I hat, plus vy in the direction of j hat. Same thing with the acceleration. The acceleration can have any direction. Like for example, if the acceleration is like this, a, will have two components. One of the components are in the tangent, and one of the components are in the normal direction, like something like this. So this is a, oh sorry, we're not working tangent normal. Let's keep them consistent, x and y. We'll talk about the tangent normal today. So we will So if I have two components for this a, so I'm gonna have like the component in x, something like this, ax, and component in y, ay. So I can write it here. A vector is equal to ax in the I direction plus ay in the j hat direction. So these are the components. All right, so let's solve an example and see how these are similar to what we learned before. But definitely we are going to use the same rules, like the same rules that, did you remember the equations that we have, the 4 equations? It's the same equations. Let's write these equations actually. Do you guys have the equations? Alright, so I believe we have the first one that we were integrating the velocity to get the distance. So it was something like s minus s node, the integration of v from t node to t dt, and this gives us s minus s node. And then you have another one that you integrate the acceleration to get the velocity, v minus d node, the integration from t node to t, and we have a dt, right? And then we have another one that we use the relationship between the distance and acceleration, and we have something v squared minus v node squared is equal to t2 a the integration. Let's put a inside. ds from s node to s, right?
It's 1/2 multiplying v squared minus v node.
Okay, I put a 2 here, so that
So it's the
happens
same.
here, same, okay. All right, so this is the general equation, but if we are dealing with Cartesian coordinate system for a body that moves in xy direction, same thing, but we will have x component, like x direction, and then we are gonna write the same equation, this one, but rather than s, it's gonna be, for example, x minus x node is gonna be the integration from t node to t, vx, component in the x direction, dt. And you're gonna have y component, y direction. And this y direction, y minus y node, equal the integration from t node to t, vy, dt. Same thing with the other equation. V in the x direction minus v x node is gonna be the integration from t node to t, ax in the direction of x, dt. Same thing in the y direction, vy minus vy node, the integration from t node to t, and this one is going to be ay dt. So it's the same thing, but rather than dealing with one component s, we are going to divide them into two components, one of them in x direction, one of them in the y direction. So let's solve an example and see how this look like. Right now we have says at any instant the horizontal position of a weather balloon. You have a weather balloon here. Here's the balloon. The balloon is flying, and it has an equation that tells you, that characterizes the position of this with respect to x and y. It has a parabolic curve, something like this. And the equation of this curve, y equals x squared over 2. Alright, so it says the horizontal position of a weather balloon is defined by x. Okay, here it says, it's defined by x equal 8t, and it's in foot. Alright, so this is how to describe x, the position in the x direction with respect to the time, where t is in seconds, if the equation of the mass y equal x squared over 10. So this is the two equations that is given here in this problem. Y as a function in x, and x as a function of t. So if you have y as a function of x, you can get y as a function of t. How? I substitute this and this, right? So this is going to be 8t squared over 10. It's going to be 6.4 t squared, right? 8 by 8 is going to be 64 over 10, 6.4 t squared. So right now I have x as a function of t and y as a function of t. All right? Okay, so what is required in this problem? Determine the magnitude and direction of the velocity and acceleration at t equal 2 seconds, right? So let's solve this. So the v and a. All right, I give you directly x and y. All right, so you can actually divide this problem into two parts. You can actually solve the problem. You can say x direction, y direction. You can solve them directly, but I would recommend whatever the way that you are organize your solution with, go with it. Like some people are very organized. I'm gonna divide this into x and y and solve them separately. So like for example, I'm gonna say for x direction, this is actually how I like it. For x direction, and then you solve for y direction. And then you solve. If you want to solve them, all of them together, that's fine. Okay, let's solve the x direction. So you have x as a function in t. So if you want to get the velocity in the x direction, vx, how can I get it? So vx is the time rate of a change of the position. So it's gonna be dx dt, right? So you need to differentiate this with respect to the time. So it's gonna be 8, right? Let's get to y. Vy is the time rate of a change of the y with respect to t. So I have y here, 6.4 t squared. So it's gonna be 12.8 t. All right, so right now I have the velocity in the x is constant, but the velocity in y is changing over time. So if you want to get the velocity vector, so getting back here, this is the velocity vector, right? So if you want to write it as a vector, v is going to be equal to 8 in the direction of I hat plus 12.8 t in the direction of j hat. Okay, so this is the general at any time, but I'm asking you at a specific time, at 2 seconds. So the velocity vector at 2 seconds, you can say t equal to 2 seconds, is going to be 8 in the direction of I plus 12.8 multiplied by 2. So it's going to be 25.4 in j hat direction. Okay, I asked you about the magnitude and direction. So this is not enough. This is the velocity vector. How can I get the magnitude of the velocity? Okay, so let's look at this. V vector is 8 in the direction of I hat, and it's 25.4 in the direction of j hat. So the resultant is going to be, so the velocity, that means this body moved this way and this way, so it's something like this. So this is the v as a magnitude. So we're going to use this like v as a magnitude. It's going to be the square root of 8 squared plus 25.4 squared. So this is going to be 26.82 feet per second. And units are very important. I give you the distance are in feet, and the time it says it's in seconds, so everything is going to be feet and seconds. Okay, I got the magnitude. I need the direction of the velocity. How can I get the direction? The direction, that means I wanted the angle with the horizontal that the velocity is making. So this is the velocity. I wanted this theta. How can I get it? Theta is tan inverse. So you guys know that? So this theta is going to be tan inverse 25.4 over 8 if you want to get this angle. 25.4 over 8. Once you do this angle, it's going to be 72.64 degree. Does anybody have any question? How did I get the resultant? How did I get the theta? So all solving this triangle. Okay, so this is the Vx, this is the Vy, the square root, and then I get the magnitude, and theta, just the tan inverse, because we know that tan theta is 25.4 4/8. If you want to get theta, you get tan inverse to both, and then solve for theta. All right, I got v. So the next part is I want to get the acceleration, right? So ax is going to be 0 because the velocity in the x direction is constant. Ay 12.8, right? It's constant. So second bar, the a vector is going to be 0 I hat plus 12.8 j hat, and it's constant. All right. The magnitude A is going to be equal to, right now I'm telling you that this balloon is moving with 0 acceleration in the x direction and 12.8 in the y direction, and it's going upward. So it's something like this. This is 12.8. So what is the magnitude? The root square of 0 plus 12.8 squared is going to be 12.8. Or you just write 12.8 because it only has magnitude in the y direction. So 12.8 feet squared per second. Okay, how about the theta? Without any calculation, it's going to be 90 degrees because it's up. Always the theta is measured with the horizontal, like this, counterclockwise. Okay, this is the horizontal, counterclockwise, it's going to be 90 degrees. Or if you want to do it, it's going to be tan inverse 12.8 over 0, and this is going to give you 90 degrees. All right. Does anybody have any questions so far? Yeah. Oh, sorry. Thank you. It's the acceleration. Definitely, it's feet over. Yeah. Talking about units, some of you has problems with converting the units in the homework. Like for example, I give you that Tesla is moving, for example, 60 miles per hour. So if I want to convert 60 miles per hour to meter per second, what I'm going to do? I need to find out how many meters in 1 mile. Okay, so the mile, it's mile per hour. This is, let's say, mile per hour. So I need to have this, and in the numerator, I need to find out how many meters in the mile. I believe it was 1609.32 meters. Okay, the hour has 60 minutes multiplied by 60 seconds. So you find out what is this value is, and you get the meter per second. If you wanted the reverse, for example, if I give you a body that's moving 20 meters per second, and you want to convert them to miles per hour, you want to find how many miles in 1 meter. How many miles in 1 meter? It's 1 over 0.32. It's 1 over the entire mile because the meter is smaller than the mile. Okay, so it's 1 over this. And this is second, and you want to convert it to hour. So the hour is bigger. So the second is 1 over 60 multiplied by 60. Okay, so this is how we convert any unit. Same thing, if you want to convert a pressure, ton per meter square, and you want to convert it to kilogram per centimeter square. Oh, okay, this. Oh, right. Centimeter square. How can I convert it? I need to find out how many kilograms in the ton. The ton has 1,000 kilograms. This is up here in the numerator. The numerator, we have meter square. I need to find out how many centimeters in the meter. So I know that the meter here has 100 centimeters, but it's a square because this is a meter squared. If this is acceleration, like I'm asking you, rather than getting mile per hour square acceleration, to get it as a meter per second square, this is going to be squared. Does anybody have any question about? Yeah.
In the exam, are we gonna have the conversion rates, or are we gonna have to do it?
I believe, yeah, maybe if it's mile, I'm gonna give you that. Yeah. But things that you need, I believe, to know is, like, for example, the gravitational acceleration is 9.81 meter per second, and in feet, 32.2 feet feet per second squared. What do you think? Right, so this is for the unit conversion. So, alright, let's solve another two problems. Or maybe, let me solve this one. Right, so this question it says that this is the sea level, and this is the base at the sea, and we have a submarine at some location, and the XY is at the base, like the origin is here. Here's X, and here's Y. And the submarine is a little bit up from the base, and it's moving with V node. So this is Y node, and this is V node. And this is V node X, right? So it's an X direction. And I'm giving you some initial condition for this submarine. The submarine has initial position R node, vector, 0, and 100. That means that the position in X direction is 0 and Y node is 100. So 0, that means it is not here, it's at the origin here, but it's up by 100 meters. Okay? The velocity V node as a vector, as an X and Y component, it has 6 in the X and 0 in the Y, so it's only have V node in the X direction. So it moves linearly as a start, but it doesn't mean that it's keep linearly the whole path. Mine goes up or down. Okay, so this is V node. Actually, I can write the vectors in different ways. Like for example, I can write this vector something like this, 6 and 0, 0%. Or I put them in a parentheses. Okay, and I'm giving you that the acceleration in the X direction equal to 0.60, and the acceleration in the Y direction is equal to 1.8 minus 0.36 t. So the acceleration for X and Y are linear. And I'm asking you, find the position function of this submarine. I want you to write me a function of time for the position of this submarine at any instant. So here's what I'm asking you, find the position function. Let's look clearly on this problem. I give you all the initial conditions, and it sounds like it's only at time equals 0. This is the initial position, and this is the initial velocity at time equals 0. And then I give you the acceleration as a function in time for both X and Y direction. I'm asking you for the position. What I'm gonna do, I give you the acceleration. Do you guys remember how to get the position from the acceleration? We wrote something like this. What was that? Yeah, so write S, and we write velocity and write acceleration. And we said, if we want to get the velocity from the acceleration, I need to do an integration. And if I want to do, I need to do another integration. So this, I need to integrate to get to the position. Here, I need to differentiate with respect to the time to get the velocity. And I need to differentiate with respect to the time to get the acceleration. So what I'm gonna do here, I'm gonna integrate or differentiate. Integrate, right? Okay, so let's do it step by step. You can do the same thing, like what I did here, X direction. And Y direction. Okay, for X direction, I need to do the verse integration. And the verse integration, if you guys remember, V minus V node, and I have the acceleration, so V, and this is gonna be Vx minus V node X, or Vx node, whatever you call it. And then the integration of Ax dt from node T node to T. Let's do it. Okay, so V node X, is it 0? No, it's 6. So Vx minus 6 is gonna be the integration from 0 to time t, and ax is 0.60 dt. So gonna continue. X direction. Y direction. Let's continue from here. So Vx, I'm gonna send 6 to the other side, to the right hand side. 6 minus the integration of 0.6t dt is gonna be 0.6t. It's gonna be 0.6t squared over 2, so it's gonna be plus 0.3t squared, right? So this is gonna be 0.6. So this is Vx, and I need you, after you finish getting something that is very, very important that you give points to, box it. That's what I used to do since I was an undergrad. I used to give whoever is grading my exam, my homework, box everything for him. Give me the grade here, give me the grade here. So I put it as a box. I don't confuse him, I don't give him hard time to find the answer. Just box it, and actually that's what I do in grading. What I do, I look at the final answer. Did you get it right? If I get it right, I overlook very fast and I give you the points. But if I looked at the final answer and you didn't get it right, so you are not gonna get the full mark for this point, but I will try to give as much point as I can based on your work. See if you messed up with some math calculation, if you messed up with some basics, and then try to figure out how much points I'm gonna give to you. But if you got the final answer right, so definitely you are gonna get the full points somehow. Okay, so I got Vx. Let's get to Vy. Vy is the same thing. It's gonna be Vy minus Vy node, the integration of a to t from t node to t, and this is definitely ay. So Vy minus Vy node. Vy node is equal to, I gave you Vy, V node as a function of, this is V node x and this is V node y. So V node y is equal to 0. So Vy is the integration from t node to t, and ay is 1.8 minus 0.36 t, and all this dt. So let's do this integration. So Vy is gonna be, if I integrate 1.8, it's gonna be 1.8 is a constant. It's gonna be 1.8t, right? If I integrate negative 0.36t, is gonna be
Negative 0.18t squared.
negative 0.18t squared. How? This is gonna be t squared over 2, so 0.36 over 2 is 0.18. Alright, so we got this, I box it, but this is not what I'm asking for. What I'm asking for is the position function, so I need to do another integration. So let's get this. So to do another integration, so it's gonna be this one. So x minus x node is gonna be the integration of Vx dt from t node to t. So x node is equal to 0 because the body started at position x equal to 0. So this is 0. So x is equal to the integration from 0 to t, and Vx is 6 plus 0.3 t squared dt. If I integrate this, it's gonna be 6 is gonna be 6t. 0.3 t squared is gonna be 0.1 t cubed, and this is x. This is the position in the x direction. Alright, so let's get y. Y minus y node is gonna be the integration of the velocity dy dt from t node to t. Y node is 100, so it's gonna be y equal to 100 after I send this to the other side, and I integrate from 0 to t dy, which is 1.8t minus 0.18 t squared dt. So let's do this integration. 1.8t is gonna be 1.8 1.8 t. T is gonna be t squared, and we divide over 2. 0.0, sorry, 0.9. 0.9, because 1.8 over 2 is gonna be 0.9 t squared. This one is gonna be, if I divide, this is gonna be t, this is t squared. So when I increase this, another degree is gonna be t cubed, and I divide over 3, 18 over 3 is 6. So it's gonna be negative 0.06 t cubed, and this is why. I got the position. So the position is, r vector is 6t plus 0.1 t cubed, all this in the direction of I hat, plus 100 plus 0.9 t squared minus 0.06 t cubed, all this in the direction of j hat. And this is the position of the submarine at any instant. So if I told you, give me the position at 10 equal 10 seconds, you're gonna substitute with t equal 10 seconds, you're gonna get r. Okay? Does anybody have any questions so far?
Just so I have like a, so just to make sure I understand, if like in the exam, I can see that the more we go, like we go from acceleration to position, the degrees get higher.
Yeah.
So that's a good way to like check, right?
That's true, yeah.
You can check.
So here I give you the position, the acceleration t. So t is gonna get higher, to be t squared if it's velocity, t cubed if it's acceleration. That's a good check.
So wait, SX and XY would be the same thing as like the R as well? Or?
Yeah, we can call them Rx, we can call them SX, we can call them X. So it's all X direction. You can call them whatever you want. So I put them X, you can call them SX, RX, X, all of them is good. As soon as you differentiate which one is X and which one is Y. Alright, so let's solve another one. So this, the one that I'm gonna solve it right now. So I'm gonna solve it in a different way than the textbook, so you can have different. Do you guys check the textbook at all? Okay. All right. So in this problem, it says for a short time, the back of a plane. So you have a plane here. Shown in the figure is described by y equal 0.001x squared. Okay, so a plane is moving on a path, is making a takeoff, and this is the path is equal to 0.001 x squared. And it's 0.001, so that means actually that it's very, very shallow. So it's something like this, and it goes like that. So it's 0.001. And if the plane is rising with a constant upward velocity, so you have Vy is constant, and it's equal to 10 meters per second. Determine the magnitude of the velocity and the acceleration. Determine the magnitude of the velocity and acceleration when it reaches altitude y at y equal to 100 meters. So at y equal 100 meters, it asks about the velocity and the acceleration. What is this velocity at 100 meters? All right. So right now I give you Vy, it's given and it's constant. So, and we know that Vy, let's put it here. Vy equal 10 meter per second. So let's get from Vy, let's get the y direction. How does the y direction look like in terms of distance? As we said, that we can, from this, we can say that y minus y node is the integration of the velocity dy dt. So if we have y, I can integrate the velocity to get the distance. All right, so y node, the plane start from y node equal to 0, so this is going to be 0. So I'm going to have that y is going to be equal to 10t. All right? So if I integrate this, it's going to be the integration of 10 dt. 10 is going to be 10t, and y node is equal to 0, and t node from 0 to t starts from here times 0 at x and y equals to 0. So I have right now y as a function of time, okay? But I'm asking you, I need to get the velocity and the acceleration at y equal 100. So right now, if I substitute in this equation with 100 meter, I'm gonna find out what is the time that I need to get the velocity and acceleration at. So if I put this, that y equal 100 equal to 10t, I can get that the time that I'm looking for is 10 seconds. So I wanted to find out what is the velocity and acceleration at time equal to 10 seconds. And this will take us to the next step. How can we use this equation? Right? But at least for now, I know what is the time that I'm looking for. At 10 seconds, I want to get the velocity, I want to get the acceleration. So let's find out how can I use this. I can, two different ways that I can use that. How? I have y as a function of t, and I have y as a function of x, so I can make these two function of time, because if I want to get the velocity, I want to integrate this with respect to the time, not the distance x. So, but right now I don't have y as respect to time, but I can make it with respect of time. How? So right now I can say that y is equal to 10t, and it's also is equal to 0.001 x squared. So from this, I can get x as a function of t. How it's gonna be? So x is gonna be, x squared is gonna be 10 over 0.001 multiplied by t. So if I want to find out, this is gonna be 1 over 1,000, so this is gonna be 10,000. If I take the square root, it's gonna be 100 root t. Does anybody have any problem with that? This is 1 over 1,000. When it goes up, it's going to be 10 multiplied by 1,000. It's going to be 10,000. Square root of 10,000 is 100, and square root of t is 1. Right, so I use all the information that is given to me right now. Right now I have x as a function of t, I can get y as a function of t, and I can solve this in x direction and y direction. Okay, x direction, I have x equal 100 root t. And y direction, I can do the same. How? I'm going to multiply this 0.001, so it's going to be 0.1. Oh, let's put that. 0.001 multiplied 100 root t. Actually, I have y as a 10t. So I don't have to do that. I have it here. Y is equal to 10t. It's going to give me the same thing, 10t, right? So if I want to get the velocity from x, so if I want to get vx, what I'm going to do? I'm going to do integration or differentiation. Vx is dx dt, right? I need to differentiate the time rate of change of the position. So can you guys differentiate this for me? Do you guys remember the differentiation of the root? So it's, yeah, what is it? Okay. So it's 100, okay? over 2 root t. So it's one, it's the, like if I have a constant here, so it's the constant all over 2 multiplied by the root. Or you can make it in an easy way. You can make this as 100, and this is t to the power half, right? So you can multiply the half here, and this is gonna be decreased by 1. So if you differentiate it, it's gonna be half multiplied by 100 multiplied by t to the power half minus 1 is going to be negative half, which is, this is going to be 100 over 2, and t to the power negative half is root t, something like this. So same thing. Okay, so I got vx. Right, how about ax? Is d, vx, dt, and differentiate one more time. Okay, so let's differentiate this part. So I need to get the time derivative of 50 t to the power negative half. How can I differentiate that? Same thing. It's gonna be, I multiply negative half by 50, so I put the negative half down, multiply it by 50, and this is gonna be t to the power negative half minus 1, so it's going to be negative 3 over 2, okay? So this is ax. So right now I'm done with the x direction. Let's do the y direction. It's very simple. dy dx is going to give me vy. It's going to be 10. ay is dvy dt, so it's going to be 0. Right, so right now I have vx, I have vy, I have ax, ay. I can get the magnitude and the direction of v and a. How? So v is gonna attend, yeah, y equal 100 meter, which is t equal to 10 seconds. So this is gonna be 100 over 2 root 10 in the I hat direction plus 10 in the j hat direction, this one. And if I want to get a, so it's gonna be this one, negative half multiplied by 50 multiplied by 10 to the power negative 3 over 2, and this is in the I hat direction plus 0 in the j hat direction. And I'm gonna do the same thing. We are gonna take the root square of these two quantities to get the magnitude, and then take the 10 inverse to get the angle. Same thing with the acceleration, right? So there's another 2 steps that I'm not gonna do them. You can do them by yourself, but it's the same concept, right?
Are you post the problems that you're doing right now on Canvas as well?
Yeah, all the notes, and actually, how's the problem on the textbook, right?
Okay.
So the solution on the textbook is a little bit different from mine. So actually, he take dy by dt, and then he did other thing, but it's most of them is gonna give you the same solution. So all of them will give you the same solution. Okay. So does anybody have any questions so far? Yeah. So I'm going to talk about an application on the curvilinear motion in a Cartesian coordinate system, which is the projectile motion. So if you have something and you throw it and it moves in a projectile, so this is what we are going to do right now. So let's see what is special about projectile motion. Chapter 12.6. Projectile motion. So projectile motion is a direct application on the Cartesian motion, okay, direct application. So all the projectile motion is gonna be solved in X and Y direction. What is also special about the projectile motion? So let's say that this is X, and this is Y, and you have a body, and this body, you throw it, so it's gonna make a curve something like this. And as we said, the velocity of any body is always tangent to the base. So this is the base of the projectile, so this is V. At any time, this is how the V looks like. The V is changing in magnitude and direction. So this is the direction, it's changing over time, okay? So for example, if this is V node where the body would throw in, so I have V node X and V node Y. This is the final location, something like this. So this is gonna be Vx and Vy, right? What is also special, it says when air resistance is neglected, the only force acting on the projectile is its weight. So at any time, if you are throwing a body, it has a constant acceleration. What is the constant acceleration? Is the gravitational acceleration. So this body, when you throw it, the gravity once it takes it down, and this gravity, A constant, or AG, is equal to 9.81 meter per second squared. So the projectile motion is an application on the Cartesian coordinate system, and this is the equations that we use, but it has a special condition, that the A is constant. So do you guys remember variable acceleration and constant acceleration? So we are going to use the constant acceleration equations. Okay, so if we are saying this is our equations, S minus S node is going to be the integration from T node to T, and this is V node plus AC T minus T node dt. This is the constant acceleration equation, and once we do it, if you look at your equation sheet, it's going to be equal to V node T minus T node plus half A constant T minus T node squared. So this is the equation sheet. Same thing, the velocity, V minus G node in the equation sheet. If A is constant, it's going to be V C T minus T node. And the last one, V squared minus V node squared, 2AC S minus S node. This is the three equations. But this, if it's a linear motion, so we put them as a general. We didn't say Vx or Vy. But when it comes to projectile, we are going to write these equations into two parts. All of them are x's, all of them are y's, and we divide our problem x direction, y direction, and solve the whole thing. Same thing like this. But this one is not a constant acceleration. The acceleration is changing over time. Ax is 0.6t, and ay has a function of t, so we couldn't do that. So for this one is a constant acceleration. So let's also see constant acceleration, projectile motion, how the x and y look like. There's some special cases here. So horizontal motion. What is special about horizontal motion for a projectile, and what is special about the vertical motion of the projectile? Okay, so for the horizontal, there is no ax. The projectile motion is always have acceleration going down, which is the gravity. And the gravity is a y direction, not an x direction. So ax is equal to 0. So let's substitute with ax in this equation. So if ax is equal to 0, so ax is equal to 0, so all this term is going to be 0. So x minus x naught is going to be v x naught t minus t naught. This is for this equation because the acceleration is equal to 0. And also the acceleration is equal to 0 in this equation too. So all this term is equal to 0. That means that the final velocity is equal to the initial velocity. Like v x final is equal to v x naught. So the initial velocity in the x direction is equal to the final velocity in the y direction. And we are talking about x direction only. Y direction is going to be completely different thing, the vertical motion. So horizontal is the x direction, and this is the y direction.
For this one, I can put the acceleration equal to 0 too. So this term is gonna be 0, and v square is gonna be equal to v node square, and it's gonna be the same thing.
Vx is equal to Vx node, so it's the same.
So it doesn't matter if I substitute two, because both of these equations is gonna give me that the initial velocity is equal to the final velocity in x direction. Let's do the same thing in the vertical motion. So vertical motion has ay equal to the ay is the gravitational acceleration. And if y is positive, so the gravitational acceleration, so it's negative g, right? Okay, so let's substitute here with negative g. So rather than having s minus s node, so I'm gonna have y minus y node equal to this one, v node, but this is vy node because we are talking about y, t minus t node, minus half multiplied by the gravitational acceleration, multiplied by t minus t node all squared. So what I did, I substitute, I removed the a, and I put negative g. Same thing here. Vy minus vy node is gonna be equal to negative g t minus t node. And this one is gonna be v square y minus vy node squared negative 2g y minus y node. And actually I can rewrite this, so this is gonna be vy equal to vy node minus g t minus t node, and I can write this vy squared is gonna be vy node squared minus 2g y minus y node. So this is the most important equation if we are talking about projectiles. This x and this y. So when I give you any projectile problem, you need to have all these equations in front of your eyes and substituting them. Okay? Okay, let's.
I have a question. So I know that this is assuming no air resistance in this like these problems, but if this was applicable in real life, then AX can't equal to 0, right?
The what?
AX can't equal to 0 because there's always going to be some kind of resistance.
Yeah, so if we are gonna account for the air resistance, so AX is not gonna be 0. It's gonna be, the body is slowing down because the air resistance, so it's gonna be included. But usually when we neglect something, we neglect was compared to other important parameters, like, for example, the gravitational acceleration is 9.81, but if the air resistance is give you an acceleration slowdown of negative 0.1. So once you solve your problem, you will find that negative 0.1 is going to affect the final velocity and the final acceleration. Like the final velocity, rather than being 12.5 meters per second, is going to be 12.49 or 12.42. So we neglect them so that we can make our problem much easier. All right. And actually, we do the same thing when we solve the structure. Like, for example, when we solve a cable-stayed bridge or a suspended bridge. So a suspended bridge, there is wire is holding the bridge itself. Sometimes we neglect the wire weight with respect to the entire weight of the structure because it's a very, very small. Okay. All right. So let's solve one or two problems on the projectile motion. So we have in this problem it says that I have a sack slide. You have a slide something like this, okay, and you put some sacks on this slide, so the sacks slide here, and once the sacks slides, it has a curve that moves on, like a curve something like this. And the sacks keep stacking here. So you have some sacks, it starts from here, keep sliding until it comes here. So let's see what details is given. A sack slides off the ramp with a horizontal velocity. So we have a horizontal velocity is equal to 12 meters per second.
if the height of the ramp is 6 meters from the floor, so if this is the floor and the height of the ramp is 6 meters, and I'm giving you that this is Vx and this is Vy. Alright? So 6 is below the system. And I'm asking you determine the time needed. The time needed for the sac to strike the force. So if the sac is starting from here at velocity 12 meters per second, how much time does it give this sac to come here? Okay? To strike the floor and the range of R. Like what is this distance? R. Okay? And R. Let's solve this. So we are gonna do the same thing. We are gonna apply in the horizontal direction and in the vertical direction. We can call it here x direction. Let's say for x direction. And for y direction. For x direction, I have these two equations. I have Vx equals Vx node, so I definitely know that, and actually this V, it says that it's horizontal, like, let's read here. It says that with a horizontal velocity, so I should have written this as Vx, horizontal velocity, not V. So the V is something like this, Vx. And this is Vx node because it's where it starts, but I knew from the properties of a projectile that Vx is equal Vx node, so the Vx here is the same here. So I know that Vx equal Vx node equal 12 meters per second. I got the first one. Let's go to the second one. X minus x node. So x node, this is where's my coordinate system at? So x node is equal to 0. Okay? But if my body started here, so x node is not gonna equal to 0. So x node, x minus x node equal to Vx node t minus t node. Alright, let's solve this. X node is equal to 0. And the final x actually is r, right? So the body started from x, 0, and ended up here, and actually r is from here, so from where the body starts from. This is r. So r is equal to Vx node, which is 12 multiplied by t minus t node, and t node is equal to 0, so r equal to 12 t. So I got the first part of the problem. So I'm done with the x direction. These are all the equations that I have in x direction. So let's get the y direction. The y direction, let's see what information that I have in y. Actually in y I have y node. It is negative 6 meters. So I go down negative 6. That is the only thing that I have. But I also have the gravitational acceleration. So I have g as well. And right now, let's just see. So I have g, and I have Vy node is equal to 0. And so here I have y node is 0, Vy node is 0. I have g, I can't get the time. So let's see this. So let's just start with the first equation. Actually, you can substitute with them, like this one first and second and third. But sometimes you can check which one that is going to solve the problem faster. So look at this one. I have y is negative 6. And I have y node is 0. I have Vy node is 0 because the sac started at horizontal velocity. So the Vy node is equal to 0. So this term is 0. I have g, 9.81. My units are all in meters, so 9.81 meters per second. So the only unknown is the time. So let's get it. So I have y final is negative 6 meters minus y node 0 is going to be equal, all this term is going to be 0 minus 1 over 2, 9.81 multiplied by t minus t node is 0. From this, I can actually get t. So once we solve this, t is going to be, oh sorry, we have here t squared. So this is all squared. So t squared is going to be equal to negative 6
multiplied by 2, and you divide them by negative 9.81. So this gonna give you something, and then you take the square root. So the time is gonna be 1.11 seconds. So I got t, and I have r as a function of t, so you can get r. R is gonna be 12 multiplied by 1.11. So it's gonna give you 13.27, and r is in meters. And actually that's what's required in this problem. Very, very simple. I give you the velocity, and I told you that the velocity v is in x direction, there is no y component, so vy naught is 0, and I give you the initial position here, and I give you the final position y, so I substitute in these two equations, and I got r as a function of time, and then I substitute only in one equation, and I pick this one because this is the easiest one. Because I already have vy naught is 0, I have y, I have everything, so I can get the time right away. But if you did this, you are going to end up with vy as a function of t. And this one you are going to give vy as a function of t as well. No, this is you are going to get vy and then substitute this and this until you get c, so it's going to take much longer time. But this just one equation is going to solve the whole problem. Okay, does anybody have any questions so far? All right, so the second question. Next time, there will be a quiz in the lecture maybe, here, so maybe you tell who's not here, on the linear motion, the very simple, okay? It's gonna be 15 minutes, all right? So I'm still trying to figure out what is the best can work for us, because I was thinking about giving a Canvas quiz that you can take it at home, but I'm not sure about the time that you guys all will be there, so it's gonna be hard, so maybe we use 15 minutes of the lecture. And it might be at some point try a Canvas quiz and see how it works with the whole number and see how everything will go. So we will swap. Okay, so let's solve the this problem. So it says that the track for this racing, so there's a racing event, and it was designed something like this. We have something like that, and you have a guy on a motorcycle here. I'm gonna represent it with this thing, and it says that it tries to jump off the slope with 30 degrees. So this slope is 30 degrees, and it's gonna, if this guy jump from this slope, it's gonna make something like this. All right, until it reaches to maximum height h. And the distance from here to here is r, which I don't know. And the coordinate system is something like this. I have x direction here, and I have y direction here. But I don't know what is the velocity that this motorcyclist is moving with. Okay? But it tells me a piece of information. Let's see what is the piece of information that I have here. Example. So for this example, it says that this slope is 30 degrees. The motorcyclist is going to jump up from this slope with an angle of 30 degrees. And it says that he remained in mid-air for 1.5 seconds. So what does it mean? Remained in the air for 1.5 seconds. That's t minus t node. T final when he gets here, and t node, so t minus t node, is equal to 1.5. I don't know what is the final t, and I don't know what is the initial t, but he gave me t minus t node, the total time period. Determine the speed at which he was traveling of the ramp. So we want to know what is the value of v. Okay, so we need to know determine v and the horizontal distance he travels before striking the ground, so needs to know R. So let's see, what is the V and what is the R? Okay, so I'm gonna use the same equations, like these equations, X and Y, but let's start with Y direction. I'm gonna tell you why. So let's say for Y direction. For Y direction, let's write the first equation. Y minus Y node equal to Vy node T minus T node minus half G T minus T node squared. Why did I do that? I have T minus T node. So I have this part and I have this part. I have G, 9.81. And I have Y node starts from 0 because this is where it starts from. And the final Y that he came to, actually this is given as well. And the problem, so here, this is 1 meter. Like it's a negative 1 meter. So I have, this is negative 1 minus 0. Vy node, I don't know it. But let's actually figure out what is Vy node and Vx node. So if I know the direction of V, so what is the value of Vx? It's gonna be V cosine 30, right? And Vy is gonna be V sine 30. So we know that. So we know that Vx is gonna be equal to V cosine 30, and Vy is gonna be V sine 30. Once I know V, I will know the other part, but I can write them here. Like I can write Vy node is gonna be equal to V node sine 30, and T minus T node is 1.5 minus 1 over 2 multiplied by 9.81, 1.5 squared. Once I solve this, I will be able to get V node. So this is gonna give me V node is equal to 13.38 meter per second. All right? Okay, so right now I can solve for X direction. So I have, because I can get from V node, I can get Vy node, so I can, sorry, Vx node, so I can get X direction right now. So for X direction, the first equation that I'm gonna have, X minus X node equals Vx node, T minus T node. So right now I can get X. X node is 0, Vx node is V cosine 30, and I have T minus T node equal 1.5. So let's write the equation here. So I have X minus X node equal to Vx node T minus T node. Right. I have X node is 0, and actually X is R. That's what I'm looking for. Right here. R. And Vx node is 13.38 multiplied by cosine 30, and this is 1.5. So this is gonna be 17.83 meters. So I got R, the very thing that it's asking for. So I got number 1. So it asked me about V when it strikes the ground. So I want to get this one when it strikes the ground, the velocity here. So let's get it as a Vy. So let's get Vy here. For V node. Oh yeah, not the velocity when it strikes the ground. Ask for determine the speed at which he was traveling off the ramp. So actually that's what we got. V is the V node, not the final V, when it strikes from the ramp. So it is this one. So we got this first bar, and this is the second bar to R. So actually we solved the problem. But I can ask, what is this height? So if I ask you for what is the height, the maximum height that this motorcyclist got to, how can I get it? Okay, so if I told you the maximum height, so if it moves on the curve, what this point gives me? Is the velocity 0? No, the velocity is not 0. It has a velocity, because if it has a velocity 0, it's gonna drop down right away. It's not gonna make it to this spot. But I know the direction of the velocity, right? So you know that this is the direction of the velocity, right? V. And that means that the velocity, all the components of the velocity are in x direction, not in y direction. So this is in x direction. So at h, you know that the velocity Vy is equal to 0, right? So there is no v in this direction. All the velocity is going this way, tangent to the curve. So I can use this and the y equation here, Vy, and I have Vy nodes, and I have g, sorry, not, because this one is not gonna give me, this is gonna give me the time when it gets to this height, but I don't need that. I need y. So I'm gonna substitute in this equation. I have Vy node 2g, and then I have y minus y node. You can substitute in both, but I'm just asking for the height, okay? So I can write Vy squared minus Vy node squared is gonna be equal to, can you guys tell me what is
Minus 2g
minus 2g?
divided by y minus y node.
Y minus y node. Alright, so Vy is equal to 0. Vy node, I already have it. I have V node here, so negative. Vy is 13.38, and y is a sine 30 squared is going to be equal to negative 9.81. Y, I want to get y, okay? So y is measured actually from here. So y minus y node is 0. So once I solve this, it's going to give me y equal to 2.28 meters. Is that the maximum height that is this guy is looking for? No, actually I got y. Y is measured from this part. But the maximum height is y plus 1. So h is y plus 1, the height of the ramp. So 2.28 plus 1 is equal to 3.28 meters. Okay? Because I have 1 meter here. And my y is just this part. Okay, does anybody have any question? So solving any problem, you need to have all these equations in front of you. And if you somehow you don't know what to do, substitute in this equation. Get numbers. If you don't know what order that you're gonna do them with this order. But try to look what givens to you in the problem. Like for right now, I was actually accidentally, I'm gonna use this equation. I'm gonna solve it, but it's gonna give me the time. The time when this motorcyclist got here. And if you did this, I'm not gonna get any points, right? Because I'm not asking for the time, I'm asking for the height. So I go for the other equation. Before I substituted in this one, and I get to the one that has y, the height, and I substituted in this equation. So I got Vy node, and then all this was function in y. I got y 2.28, I plus 1, so it's a 3.38. Correct. So right now we are done with the Cartesian coordinate system and the projectile motion, which is a direct application on the Cartesian coordinate system. Next time we are gonna try the tangent normal motion. Just 1 second. I have an office hour. If somebody have any problem with the homework, I have 1 hour. I'll be in my office, EC 3626. If you have any question in the homework, any question in the lecture, you can stop me. Okay. Now, until
Bro, you take this